Hey, grade 9 students. Here I am at page 24, starting the correction. So for anyone who needs help, just going to go through this and go at it. Okay, first off, this is drawing circuits. They want a 9-volt battery. Now, a battery in itself is more than a cell, so you can right away put 2 because it's a battery and write 9-volt under it. An ammeter, so I'm going to put an ammeter, a 25 ohm resistance, and a series circuit. Include a voltmeter, so I'm going to put in a voltmeter like this. Remember to label positive and negative ends of the ammeter. So here my battery is a negative, this is the positive side because this is the bigger one. This is the negative, so this would be my positive and negative side of my voltmeter. And positive goes with positive, negative goes with negative for this side of the ammeter. Okay, what is the reading on the ammeter? Here they're asking me to calculate current. I have my beautiful triangle that I use all the time, and I equals V divided by R. I have V at 9 volts and R at 25, so this becomes 9 divided by 25. And I'm sorry, I have to calculate this. Gives me 0.36 amps. I believe I made a mistake in your answer sheet because the French copy had only 5 ohms, and so yes, the answer is 0.36 and not the 1.8 that is in the answer sheet. Alrighty, this other section. What would be the reading on the ammeter if we added a second 9 battery volts? So if we added a second 9-volt battery, we would, in series, we would just add them up. And this is actually the answer for number 4, okay? And so if we had 19 volts instead, the current would still be V over R, but V now is 18 and R was 25. And so that just doubles up as 0.72 amps, which is also an error that I had in the answer sheet. I had written 3.6 amps, and for you guys, it is 0.72 amps. Okay, do an electric circle of a battery that has 2 1.5-volt cells, a switch, 2 light bulbs. Everything is in series, they're asking. This, add a motor in parallel between 1 light bulb. This would be something that looked kind of like this. So it is between this light bulb. Indicate the direction of the flow. So since this is a bigger bar than that, this is the positive side, this is the negative, so current is going out from the negative. Both intensity, no, okay. So the question here says, would both light bulbs have the same intensity? And the answer is no. If you look at closely, the green here that I'm doing is the flow of one pathway of electrons that would go through the motor and come back. This is one option for the electrons. And then there's also a second option, which would go in the other pathway. So as you can see here, there's twice as much current going in this light bulb than in this one, because this one is in that pathway where there's 2 flows going through. So this one would be brighter than this light bulb. Okay, you look at the circuit here. Current is going out through here, going all around, or going through here, or going through this one. So you see right now that there are 3 lanes of flow coming back in these areas. 2 lanes here and only 1 lane there. And in each pathway, there's only one set of a flow. So circuit breaker protects which wires? Well, if you look at the pathway that the circuit goes around, it would protect the heater and furnace motor. Okay, so it's connected to those. Is this in the best location? No, because it's not protecting all of the components in the circuit. If the circuit breaker were in an area where there's more current, then it would be protecting the whole circuit. If both switches are open, this switch here and this switch here, does the heater work? And the answer is yes, because the flow can still go around. There's just no more flow going in these 2 guys because those 2 pathways are open. And so the flow will still be able to go around like this.